For this example, we calculate the limit as x goes to 0 of sine of x over x plus sine of x. And so with trig functions, we have a sine of 0 being 0. And we've got 0 plus sine of 0 on the bottom. So we do have a 0 over 0 situation here. And back before we had L'Hopital's rule, we would then, anytime we had a 0 over 0 situation, try to figure out what sort of algebraic manipulations we could use to be able to find the limit, or perhaps special limits. What could we use? Well, for this one, we don't have a real great, quick, easy algebraic manipulation that would cancel something out, but with L'Hopital's rule, since we have first verified that the indeterminate form is one of the appropriate ones, this one being 0 over 0, we can apply L'Hopital's rule. So we have the limit as x goes to 0, and we're going to have the ratio of the derivatives here. So on the top, we're going to be looking at the derivative of sine of x, and on the bottom, we're going to be looking at the derivative of x plus sine of x. Well, the derivative of sine of x is cosine of x, so we're looking now at the limit as x goes to 0, where the top now is cosine of x. And the bottom would be the derivative of x, which is 1 plus cosine of x. Okay. So now we try to take the limit again by plugging in, and we have cosine of 0 over 1 plus cosine of 0. And the cosine of 0 is 1. So we're looking at 1 on the top and 1 plus 1 on the bottom. So our final answer there is going to be 1/2 after one application of L'Hopital's rule. Now really, the nice part about sine and cosine is they kind of flip-flop back and forth when we're talking about derivatives one after the other. And their values are kind of flip-flop between the 0 and the 1, depending on where we're looking at for our C. And so while sine was somewhat problematic because when we did the evaluation we got the ratio of zeros, cosine was not so problematic because when we plugged in we didn't get zeros anymore, we got the ones. And so that allowed us to be able to tackle this particular limit.